Good morning. It is now 9:30 and time to start our next live lesson on plastic pollution. Andrea, can you please stop sharing the technical support slides so I can get our day started today? So good morning. Today we're going to learn all about plastic pollution. It's slightly different to our litter and waste live lesson. If you were part of that, it's all about what seems to be a very popular topic for schools to be talking about right now is all kinds of plastic waste. So hopefully you can see our welcome slide. Just having a slight technical issue. There we go. So to get us started, our planet has existed for 4.6 billion years. And in that time, it's hosted all sorts of life for more than 3/4 of that time. But lately, we're seeing that beautiful natural landscapes like this, which, as you know, we have plenty of in Scotland because we're very lucky, are being transformed into something that looks like this. Is not good. So with human presence in the shape of waste, and particularly in the form of plastic waste reaching all corners of our planet. But how did we get here and what could we possibly do to stop this? So this is what we'll be learning about today. When were plastics first invented? I found this one actually really fascinating because I learned a few things. How some of these inventions happened, why there was a need for materials like plastics, what positives and negatives came out of the invention of plastic, and what should we do and stop doing? And there's a few things we'd like you to do this week after this live lesson. First of all, as always, if you can, I mean, it's pouring rain today where we are. Maybe it's not where you are. But if you can, please go out for a litter pick because we cannot allow all of that plastic and litter to keep harming our wildlife. And second, we have a really interesting activity for you to choose something about what you would like to, about what you've learned today, something that has surprised you or inspired you. I'm going to turn my volume up a bit. There we go. And create a comic strip that might help others learn more about plastics, plastic pollution, and what we can do or stop doing to help the planet with the problem that's been created. There is a template in the resources folder that you can use, or you can draw your own. And if you like a challenge, we have another activity called Lights, Camera, Plastic, which is an opportunity to share your thoughts about plastic pollution in a 3-minute campaign video to tell everyone else about the issue and what everyone can do about it. And that activity and more about it is also in the resources folder if your teacher would like to have a look at that. Now, I'm very excited because I get to announce our first workshop. We have Emma Glencross and Kirsty Crawford. Emma is my colleague from Keep Scotland Beautiful, and Kirsty Crawford works with the Marine Conservation Society. And they're going to have our first workshop today and tell us all about plastic pollution. So I'm going to stop sharing and let you take it away. On you go, Emma.
Good morning, everyone. Yo, hope everyone is doing very well for a Monday morning. So I work in the campaigns team at Keep Scotland Beautiful, and one of our key roles is keeping an eye on the amount of plastic and litter that's in the environment. So I'm going to give you a bit of an overview on plastic pollution. So to start this, I would like to introduce you to Barry the Bottle. So Barry is one of our litter characters. So See, across the bottom, we've got all these different types of litter that we find in the environment, and Barry is our key for today. So given our lesson is on plastic pollution, so I would like you to keep an eye out for Barry in the presentation today, and even see if you can count how many Barrys you see in the presentation today. So keep an eye out for him. So to get your brains into gear this morning, we're going to start with a couple of questions. So teachers, I'd love you to get ready to put some answers in the chat. So to start with, we'll start easy. Where do you think plastic comes from? Now I've got 3 options here and I'd like you to have a look, and teachers, if you could pop A, B or C into the chat, that would be fab. And I would very much like you to put your answers in by the time Barry here gets from one side of the screen to the other. So, does plastic A, grow on trees? B, is it made from fossil fuels? Or C, does it come from the shops? I mean, that's where you get it from. What do you think? How are we going? I'm getting lots of answers coming through. Oh, I can see lots of B's coming through as well. Oh, look at them all. Oh my goodness. Well, plastic comes from fossil fuels. So fossil fuels are things like coal and oil and natural gas, and they are made from the decomposition of plants and animals that were on Earth millions of years ago. And all of that decomposing stuff combined with geological forces, the squishing of the Earth, has produced these fossil fuels. And so they're found under the Earth's crust and like deep down under the oceans or under the land, and they contain this carbon and hydrogen and can be burned for energy. So that's our fossil fuels, and that's the basis of plastic. So this crude oil and the natural gases that are extracted from deep underground, so under the land or under the oceans, and they're mixed with chemicals, especially acids, in the process to form these little plastic pellets. So you've got little Lego lady for size. So they're really quite small. They're sort of about the size of a hammer bead. And they form the basis of most of the plastic that we find around us. And then these little plastic pellets are melted down and molded into the shape that they're needed. So whether it's the bottle, like Barry the bottle there, a water bottle here, some plastic cups, it's molded into the shapes that we need it. So that's where it comes from. A second question is, how long's it been around? So when do you think modern plastic was invented? Again, keep an eye on Barry going across the screen. And do you think that plastic was invented, this modern plastic, this polyethylene stuff, was made around 1800, B, around 1933, or C, around 1970? How long do you think it's been around for? We're getting some answers coming in. Gosh, you're quick off the mark. Oh my goodness, lots of B's. There's a couple of A's, B, C's, B, 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 B. Excellent. I'm loving this. There's lots of fabulous answers. Do you think that, like I'm saying, that plastic's made from fossil fuels? Has plastic been around since the fossils? I don't know. No. Modern plastic was invented around 1933. So it's been on the planet for nearly 100 years. But think about what it's in. It's in so much stuff. So the plastic that was made around 1933 is this chemical called polyethylene. So that's made from those fossil fuels and mixed with chemicals like acids. So since 1933, and you think about nearly 100 years, you look around your classroom and think about all the things that are made of plastic in your classroom, whether it's the water bottles, plastic bags, pipes for construction. When it was very first invented, plastic was used to insulate cables that were used to share radar around the world around the time of the war. But the other thing to keep an eye on is that you might not even think about is that all of this stuff in your classroom, the handles of your scissors, your pens, even the bristles of your paintbrushes are often made of plastic. So plastic is everywhere. So thinking about the plastic being everywhere, do you think, this is our last question for this little bit, do you think plastic is a good or a bad thing? This is kind of a tricky question, really. So keep an eye on Barry. What do you think? I'm interested to see what you guys think. Do you think plastic is good or bad? We've got some bads. Bad, 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 bad. Good, good, bad. Lots of answers coming through. I think this is a really interesting question. So Barry's got across to the other side. So, oh, both. Oh, love it. We've got lots of boths coming through now. Oof. Well, I think both is a fabulous answer because there isn't really a simple answer. There are definitely some benefits of plastic. So plastic has replaced the way people used to use some animal products. So things like piano keys used to be made from ivory, like the tusks of elephants. And even things like the rims of my glasses, back a long time ago, that would have been made from actual shells of turtles. But now it's made from plastic. It's also that important for building materials like the pipes. It's also used in medical treatment and even in space exploration. It can be used in so many different ways. It helps us to communicate. The undersea cables used to be made from metal and that could rust, but the plastic allows that to last. So plastic is great because it can be used in so many different ways and it lasts for a really long time. So think about those last two. It can be used in many different ways and it lasts for a really long time. So what about the problems with plastic? Well, it lasts for a really long time and it can be used in so many different ways. These are good things and bad things about plastic because it lasts. I mean, I've been using this water bottle. I think I've been using this water bottle for 15 years, which is slightly scary. I have washed it, I promise. But so one of the benefits of plastic is also one of the bad things about plastic. And so we've got so much of this plastic around, but it doesn't break down. It doesn't biodegrade. It breaks into little pieces, smaller and smaller pieces. And the litter itself, the plastic, can damage the environment if it's left in the environment. So, and also it's made from these fossil fuels. And more fossil fuels are used in the manufacture. So there's a lot of problems with plastic as well. And when you think about, actually, this is something else that's made of plastic. Jumper. Plastic fibers. And so when we wash our clothes, little pieces of plastic can end up getting washed out into the ocean. So thinking about this plastic not breaking down, how much plastic is there? So this graph shows the cumulative amount of plastic. So that means like all of the plastic that's been produced and it's still here, and more is produced and it's still here. So we are now up to around 8.3 billion tons of plastic hanging around the earth at the minute. This makes Barry very sad. So thinking about 8.3 billion tons, that's a lot. So another way of saying that is 80 million blue whales. The blue whales are the biggest creature in the world that's ever lived. Like, they're bigger than the dinosaurs. So 80 million of those is how much plastic is around the earth. About 1 billion elephants. This is a lot of plastic. This pile of waste is just getting bigger and bigger as we produce more, and it doesn't really go away. Because what happens to it? So only around 9% is recycled. 12-ish% is incinerated, which means it's burnt, which means it does go away. There's no more plastic left, but lots of very toxic fumes end up in the environment. So it ends up being around 80% nearly ends up in landfill or littered in the environment. And this is where it just ends up, and that's not great. So what about in Scotland? So the campaigns team at Keep Scotland Beautiful, we've got a few programs on where we're looking at the amount of litter in Scotland, and we've got a program called Upstream Battle. So it's looking at the amount of litter that we're finding on land and on its way to the sea, because 80% of litter in the marine environment, in the oceans, actually comes from land. So we're finding out litter along the Tay, so from Perth out to Dundee and along the River Clyde. And then my program is called My Beach, Your Beach. So we're looking at litter on 7 different beaches around Scotland, trying to find out how much litter there is and what it's made up of. So these are our top 10 littered items. There's lots of images there, but they are our top 10 littered items. The one on the left is of the Clyde River, and the one on the right is on the Tay River. And you can see lots of these little pictures. The things that we find littered are largely plastic. The number 1 on both of these is cigarette stubs. And you may not know it, but cigarette stubs have lots of plastic within them. They're made of plastic. They're classed as plastic waste. So that ends up in the environment, and it's really bad. Also, these little bits of plastic pieces. So plastic pieces is something that might have been a big solid piece of plastic, but has now broken down into tiny little pieces that just end up in the sand. There's also the packets from crisp packets or sweets packets. There's our plastic bottles, and even we list them separately because we also find lots of plastic bottle caps separate from the bottles. So these can be separated from the bottle, and then they end up floating around the environment, and they can be found on our beaches. So these are some of the things that I've found on my surveys on the beaches. So you can see lots of this litter on the beaches. There's these plastic bottles. There's the plastic snack packets. There's more bottles over here. Sad Barry in the bottles on the beach. There's cigarette stubs. So when I pulled out, see that the picture in the middle at the bottom there, when I pulled out lots of the waste in just 100 meters of beach, it ends up that around 20% of this is sort of fishing related. So it's got into the marine environment from the ocean, from fishing. And then all of this other stuff, this 80%, has come from land. So it might have washed out into the seas and then been washed back up onto the beach. So it's this about 80% of this, the litter in the marine environment comes from the land. So just a reminder, some of this plastic litter, it ends up in the sea, and that's what we call marine litter. And so this is bad. It's harmful to birds. It's harmful to fish. It's harmful to mammals. All these critters can get confused, can try and eat it. And it also makes our rivers and our beaches really messy and unclean for locals and for visitors. And it ends up being really expensive and really difficult to clean up. So to look more into the marine environment and what are these impacts on biodiversity, I'm going to pass back to Kat, and then we will pass on to Kirsty from Marine Conservation Society to hear some more.
Thanks, Emma. That was great. I can't believe the size of the numbers that you're talking about there. That's really difficult to think about how many billions of elephants or millions of whales worth of plastic there are floating around in the earth somewhere. But now we get to hear from Kirsty Crawford from the Marine Conservation Society. Kirsty, are you with us?
Hello, yes I am. Can you hear me and see me?
Hello.
Yes.
I think you're on mute though.
Uh,
Oh no, maybe you're not. Maybe
No.
it's me.
Can you hear me?
Yes.
Okay.
It's definitely me.
Good.
Right. Take it away, Kirsty.
Let me just start to share in 1 second. Okie doke. If someone's there, give me a thumbs up if you can see my screen now, because you've all disappeared, apart from Kat, I think. I'm going to just take that as we're all good. So I'm going to talk to you a little bit about marine plastics. So as Emma just said, this is more about what happens in our ocean environments and how plastic can impact. So some of these pictures might be familiar. When we think about plastic and how it makes its way into our sea, it's got to come through our waterways. So places exactly like our rivers, we can think of the Clyde or the Tay, like we were just speaking about. And then once it hits our ocean environment, it can take a couple of different forms. So in the top corner, you'll see these little plastic pellets that Emma had mentioned, our little nurdles. So before plastic becomes an object, just as a refresher, it starts out life as these tiny, tiny pellets. You can imagine if these make their way into the sea, then maybe the next logical place with the tides that push in and out for these to wash up is on the beach itself. So we've got a couple of images of a beach in the background. So one is really littered with lots of drinks waste, so things like plastic bottles. We've got some milk cartons there. And our bottle in the ocean on the right hand side, you can see at the top it's a full bottle, and underneath it's starting to break up into smaller fragments. So these messages that are getting repeated to you are essentially that we can think of plastic as one single object, but potentially the danger comes when it starts to break down in our environment and become smaller and smaller. The middle picture is cotton bud sticks. Now, sometimes these end up in the sea because they are either on purpose or accidentally flushed down the toilet. And I've put this image here because you might be able to think of a few ways that these cotton bud sticks might be really harmful to animals in particular once they get into the sea and even once they wash up onto the beach. And then our final image down in the bottom corner is a collection of waste that was gathered during a beach clean. So some of you might have done litter picks certainly before. Some of you out there maybe even recognise me, and I've come to see you in your school, or I might have even taken you out onto the beach. And if we were on the beach, we would have taken part in a beach clean where we tick off everything that we find. And at the end, we get this real clear picture of just how bad or good the waste is on the beach. And this bottom picture, you can see lots of cigarette stubs in here. Now, some of these objects, if you think back to Emma's chart of the top 10 items that were found in the rivers, might also ring true. And that would make sense, wouldn't it? Because if something's in our river, then it's going to eventually end up out to sea. So some of these objects might be exactly the same. So we've got cigarette butts, lots of paper, some straws, some caps and lids from bottle tops. So overall, marine litter and litter in the environment in general is quite similar. The differences might be some of the effects, some of the potentially harmful effects that they have on the wildlife that lives in and around our coastal environment or even out to sea. Some of these pictures are a tiny bit upsetting, but they do show the very true reality of what is going on in our environment right now. I'm going to describe them and I'm going to tell you some of the outcomes as well. So there are three main ways that plastic is impacting wildlife right now. The first is called entanglement. So what that basically means is being trapped up or wrapped up in litter. So this seal was okay in the end. So we've got lots of programs out there from people that are medics that can come out to do emergency rescues at sea. And we've also got lots of brilliant vets in this country as well. But this shows a really good example of being tangled in fishing related litter, which Emma also spoke about. The next one is a cause, or what can happen if you get tangled in the litter for too long. So sadly, it's showing a little bit of a cut. It's a little bit worse than it looks on this seal, but cuts become infected. So if you've got something trapped around you and it's rubbing away as you try to escape, it might become a little bit infected, which isn't so good. And finally, the creatures that swim in our seas, we've got a small shark here that's been completely tangled in some fishing related gear as it tried to escape. But these are some of the realities. Most of the time we have a positive outcome, but some of the times it's a negative outcome. But it just helps to give us a picture and understand why we can help take action. The second one is called ingestion. So I wonder if you can have a think what that word means. These pictures might help you. So we've got a turtle here in the first one, a bird in the second, and another bird in the third. And what links them all is that, so ingestion basically means if you were to swallow it and it was to end up down in your tummy. So 3 problems here. Ingesting plastic is not the best overall. Plastic can sometimes feel like food. It can maybe feel like the animal is eating and eating and eating and wanting to feel full and satisfied, but plastic will never ever do that. So what might end up happening is that you go hungry, despite the fact that you might be munching on things in the environment. The bird in the middle photo, that's a balloon, in fact, so it's a piece of rubber marine litter and it's trapped around its beak. And in the final image, we've got lots and lots of bottles that you might be able to spot with brightly coloured lids that are littering and suffocating the environment. And they're basically becoming easier to spot on the ground than the actual food that the birds need to survive. So they're almost being swamped by plastic. And that leads on to the third one, which is on suffocation. So this one here, we're talking about our turtles again. This is half of a plastic straw, which has become a little bit lodged in one of the nostrils of this turtle, making it really hard to breathe. So suffocation can, because of you finding things, because of you're finding it hard to breathe, and it can also be if you were trapped. So we've got an octopus here who's managed to wedge itself inside a plastic bottle. Octopus are very, very clever. And this is potentially a hiding place for this animal. But all the same, we recognise that a plastic bottle should not be a hiding place. It's not a natural thing. It's a man-made object that's entered our marine environment. And finally, this photo shows the choking effect of plastic. So a lot of it will sink down to the bottom of the ocean. And what this photo shows here is the plants and the animals that live on the seafloor, they're finding it really hard to breathe, to get enough oxygen or potentially sunlight, because it's basically like putting a big blanket or carpet of plastic over where you would like to live. So 9 different photos showing lots of different outcomes that having plastic in our ocean environment can have. But I want to zoom in on one photo in particular, which was of our turtle. So we're going to call these marine turtles, of which we have 7 different species, so 7 different kinds of turtle across the whole world. Now, I'm going to ask you a question, and I would like you to do a bit of a stand-up, sit-down on this one. And my question to you is, thinking about marine turtles, do you think we have marine or sea, so the same thing, sea turtles, marine turtles, do you think we have these sea turtles in our waters in Scotland in particular? So if you think the answer is yes with a big tick, I want you to stand up. If you think the answer is definitely not, don't be so silly. They only like warm water, then I want you to keep your bum in your seats. I don't need to know the outcome of this, but I'll let you crack on for 10 seconds more or so. So if you think the answer is yes, you need to be on your feet. And if you think the answer is no, stay seated and show everyone what you think the answer is. Okay. Let's have everybody sitting down again. I know that might be quite loud in the classroom. So let's have everyone sit down and we will reveal who was right and who was wrong. The answer is yes, we do. And in particular, so a little round of applause if you were standing up to show that you thought the answer was yes. Well done you. In particular, we have one of the biggest turtles in the whole world, the leatherback turtle, come right over here to where we are in Scotland, usually during the summer months every year. So I've got my little leatherback turtle fact sheet, and then I have a very special surprise for you. So this is the biggest turtle in the world. They're absolutely huge. They're about 2 meters long. Now, unfortunately, they're vulnerable to extinction. So let's take these 2 words. Vulnerable puts them in a bit of a dangerous position. It means that they're not completely safe because they have different factors or different reasons happening in their environment that's making their position a little bit unsteady. And hopefully we recognise extinction as well, meaning that if an animal was to become extinct, it would disappear forever. There's no coming back from that. That means that they might have been overhunted, or they might have caught too many diseases to be able to have enough babies to keep the population going. In one way or another, extinction means that animal is going to be gone. And so we see our leatherback turtles sitting just about in the middle, so not completely safe and okay and not critical down at the other end, but they're in the middle, and I'll explain why in a little minute. This turtle is the deepest diver. So turtles are reptiles. They are amazing in the water, but the leatherback turtle has a special adaptation. So there's something quite special about it that means that it can go much, much deeper than all the others. And I'll tell you a bit about that in a minute as well. But the longest dive that was ever recorded, so some scientists popped a tiny little camera on the shell of one leatherback turtle, and it could measure how far and how long it was going down, down, down into the ocean. So 85 minutes was what was recorded. So an hour is 60 minutes. So this is an hour and 25 minutes, which is a very long time. And to put that into context for all of you, that would mean that you would take a big breath in and then hold it for an hour and 25 minutes, which I really don't think any of us could do or should try to do. The leatherback turtle is absolutely amazing. It's such a privilege to get it, sightings of it coming to Scotland and to have it in our country. This is a photo of one that was spotted in a sea loch, so where the sea turns into a big kind of body of water. It was taken by a fisherman, and it's kind of near Argyll. And it just popped its head up, and there was two fishermen in a boat that thought, what's that swimming in the water? Lo and behold, it's the biggest turtle in the world. Can you imagine how shocked and happy you would be? So as a treat, we have a mascot here at the Marine Conservation Society. His name is Stuart, and he is a life-sized leatherback turtle that was created by an artist. So if I can set this up to work properly, I'm going to stop sharing my screen, and he's right here in the room with me, going to swim into view. And I just want to show you how big and how amazing they are. So if I stop sharing my screen and come back to you, hopefully you can see me full size. I'm going to have to walk you all the way over here so that he can enter our screen. And then we should be ready to say hello. So let's get my table out of the way, give him all the space that he deserves. You can see him sort of sitting here in the corner. Now, if I try and lift him up, it's a big effort. So here he is, life-sized, very heavy, might I add, leatherback turtle. You see my legs sitting at the bottom. Hopefully that gives you an idea of just how big he is. If I turn him to face you, he'll say good morning, everybody. You can give him a little tip of your head. That's very polite if you're a turtle to say good morning. Yeah, wow, huge. Yes, he is. So if I can sit him down on the floor, I'll leave his thumb sticking up in the air. I mentioned so the biggest in the world. So if you take a look at the door to your classroom right now, my door in the room is just behind me, he's about that tall. So from end to end, if you look at the door, that's how tall he is. And then if two of you put your arms together like this and join up if you're sitting next to someone, if you're arm to arm, two people, that's about how wide he is. So he's got these huge flippers on the side that help him swim through the ocean, and they're over 1 meter long. I really just can't emphasize how giant he is. His special adaptation that helps him dive so deep is that the other 6 types of marine turtle have really hard shells. So if you think about what a turtle looks like, you think, yeah, they've got the shells and they're made up of these kind of patches. They're really, really hard, and they're not able to move at all. If you're a leatherback turtle, your shell is squidgy. So when we press down on the top, it can collapse in the middle. So it's made from a slightly different material, and that means that when they hold their breath and they go down into the water, all the pressure that's pushing down on top of them means that their shell can bend in and fold like this. It doesn't cause them any pain. It's a really fancy way that makes them the biggest and the best hunter out of the turtles in the world. If I was to lay down on top of Stuart, I wouldn't even be as big as him. His name is Stuart after the artist who created him. I'm going to swim him off camera so you can say goodbye. And if at some point I ever come to see you in your school, I will bring Stuart with me and we can all say hello. But for now, we can do the flipper sign to say goodbye. So one hand on top of the other, thumb sticking out. Give it a little wave like this, and we can see him off on his journey back out to sea or back out to my living room. Goodbye, everybody. Let's just chuck you back to the side. Now, I'll come back to you all. I mentioned that they do come to Scotland in the summer months. So that means, where do they spend their time the rest of the year? I have a few final slides to show you exactly where they come from, and then we'll pass back over. Let's get set back up again. So we said hello, we saw how big he was, we understood that his shell is soft and collapsible, allowing him to dive down into the ocean. They actually begin their lives in the Caribbean, so halfway across the world in warm tropical waters. So we've got another photo just to show how big they are here. This is a mother and she's about to lay her eggs, and in the top corner that's the moon, so they only come out to lay their eggs in the night time. Now, after 2 months, little baby turtles called hatchlings will hatch out. So they'll have been buried under the sand on these tropical beaches, and then they'll start to hatch out, come to the surface, and then they want to head out to sea immediately because they want to try and find some of their favourite food. So they want to be out swimming amongst the ocean looking for this, which is their favourite food. Wonder if you can tell what it is. The jellyfish. Now this one here is the lion's mane jellyfish. The tentacles that are streaming off the bottom there are about as big as our leatherback turtle. This is a huge jellyfish. Now turtles have a special adaptation around their throats. They've got really thick muscles and spikes in their mouth that protects them so they don't get stung when they feed on jellyfish. Now I wonder if we go back to what the underworld water looks like for the jellyfish. Are they all jellyfish? Or put your heads together and let's have a couple of answers in the chat if you think you can spot a different object. So some certainly are, they're the moon jellyfish, the transparent ones. And others might be an object of plastic pollution. So you can see what you think. I'm actually completely blind. I don't have the chat box in front of me. So I'm going to hope that it's working and reveal the answer to you. So this might be a common one that you already knew about, that turtles, whose favourite food are jellyfish, can often get these confused with plastic bags, which is what some of these are on your screen right now. Now, this is a very real problem, and this collection here of different packages and plastic bags was removed from a leatherback turtle who washed up down in Dumfries and Galloway. So if anyone's joining us from down there, hello to you. This is in Wigton, actual fact, from quite a few years ago now. But the vets, when this turtle got taken in, had a little look in their stomach and found that it was almost 100% plastic. So the turtle thought he was very full because he was munching on food, but in actual fact, he was almost starving to death. We have, just to finish up, such a beautiful and rich underwater environment, and you can see that our jellyfish are included in this collage with lots of other wonderful animals. So the story of our leatherback turtle and the fact that they do come to Scotland and the fact that they are still confusing their true and natural food of jellyfish with plastic bags is just one of the reasons why we should still try and protect and make sure that our beautiful ocean is healthy for years to come. So my top 3 suggestions to help the ocean in particular would be beach cleaning, rethinking how we use plastic, and using our voices. So a beach clean might look something like this. There's lots of different charities and organisations out there that will help you get started, including ourselves. It's even something that you can do in your own time with family and friends. Get out there and clean up our beaches. Think about the way that we use plastic. So these are the 3 common ones about reducing and recycling, but there's also some suggestions on the screen about refusing completely, rethinking and trying to get creative, and also repairing our clothes and our objects so that they last for longer. And finally, you can use your voice in lots of different ways by writing letters and hosting assemblies, but my favourite one is to use art. Hopefully you're an art and crafty bunch out there, and you can create collages and pictures with messages of hope for the ocean to show that you really believe that change is possible. Thank you so much. I hope you enjoyed meeting Stuart, our leatherback turtle, and I'll pass back now.
Yeah. Hopefully you can hear me a bit better. I've started using a microphone. So, but thank you so much. Kirsty, for talking to us all about the turtles and everything that is going on with marine plastics. It's actually quite frightening how much a plastic bag looks like a jellyfish, and you know, just how dangerous they are to such a beautiful creature like Stuart. Let me just get this up. So now we're going to go for a wee break, but first I wanted to say, if you, oh, I'm having a bit of an issue. Hold on. There we go. First, I wanted to say, if you had any questions for Emma or for Kirsty about turtles or plastic pollution or any of the other things that they were talking about with us this morning, please, you can email them to us at ecoschools@keepscotlandbeautiful.org. I can see that there are already questions coming in. Can turtles see colors? That's a brilliant question because I have no idea and I would love to find out. What we'll do is we will try to find out the answers to all the questions that you have. And if you're able to join us on Friday, we'll share all the answers at our assembly. Don't worry if you're not able to join us live on Friday because we'll record it and you can watch it later. Okay. And now we're going to go for a wee break. If you're not going outside for your break, or this isn't your break time, we have a couple of games to play while you wait for our next workshop. But if you're taking a break, we will see you again at 10:40. Okay, and I hope if it's not raining where you are, you're able to get some time outside. So I'll just put up this game. Please don't put your answers in the chat because we're going to find out the answers together after the break. And if you share your answer in the chat, then you'll tell everyone the answer, and we don't want that. Okay, so we're going to play a little quiz and we're going to play a word search. And if you are going outside, don't worry about missing them because they'll be in the resources folder. You can play them later on. Okay, so we'll see everyone at 10:40 and we'll get our little quiz started. Right, turn my camera off and here we go. Going to look at how long things take to decompose. Just write your answers down as a class or yourself, either on your whiteboard or a piece of paper. And then after the break, we'll have a check and you can tell me how you did. All right, let's see if anyone can get them all correct. in case you're not sure what this object is, this is our colleague Colin dressed up in our chewing gum mascot costume. So this is meant to represent a piece of chewing gum. So have a guess as to how long you think that will last. It's our last object, and then we will be doing our word search. So I'll leave the word search up on the screen for you to find as many words as you can. You can let me know if you find them all. But don't say where they are, because if anyone isn't able to do the word search just now, they can do it later in the resources folder. Here we go. Good luck finding all the words. Just write them down when you have found them. Okay, and we'll be back at 20 minutes to 11 or 10:40. See you then. Hello, everyone. I hope you had a good break. That's 10:40 now, so we'll start again. First of all, thanks to whoever asked how many berries there were in the chat. I've got a treat for you because we're going to hear from Emma just now about the rest of her presentation and how many berries there actually were. So if you were counting along, keep your guess in mind and let's see if you were right. Emma? There we go.
Thank you. Yes, hope you've had a good break and that you have remembered after you've had your break to put your litter in the bin. So this is one of our signs that, one of our big messages is to make sure that you bin your rubbish. Or if there's no bins around, you take it home with you and either put it in the bin or put it in the recycling. Binning your litter is really important. We don't want that plastic pollution to end up in the environment. But binning your litter is really just one part of the story. We also need to reduce how much plastic that we use. So much of the plastic that we have is designed to be used just the once and then thrown away. And it's such a waste of all the resources used to make this plastic. But there's more that we can do. And we can think about how we use plastic. And like Kirsty said in her presentation, that we can work out if we can reduce more of this plastic. So you think about maybe after lunchtime, there might be loads of litter that's blowing around the school playground. And lots of it might be these empty plastic bottles or plastic crisp packets or snack packets. And these things are all just used once and then popped in the bin and never used again. But lots of people have been taking action, using their voices, making lots of noise about the issue of single-use plastic, in particular things like plates and cutlery and straws. And so now new rules have come into force in Scotland this year to ban commonly used single-use plastics. So things like plates and straws and cutlery, and even the polystyrene takeaway containers and lids from coffee cups, these are all banned. So you can't supply them or use them commercially anymore, which is fantastic. And it's not just the plastic even. So our single-use plastics are not good. They're used for minutes. They last for centuries. But also there's lots of resources needed to create these single-use plastics. They make poor Barry sad. So they use lots of this. There's water and carbon and resources to produce these items, and so often they end up in polluting rivers and the oceans. But it's not just those single-use plastics, because one of the things that I've found on my surveys on the beaches is that while you don't get so many of the plastic forks, now found lots of wooden chip forks. So in the middle of this slide here, there's other single-use products. So like a wooden chip fork, it's better than plastic, but it lasts a while as well. They're often hard to recycle, end up in landfill, and they take lots of resources to make. And as I've definitely found, they can end up as litter again. So it's the changing the way that we're thinking of these using reusables rather than single-use products. So thinking about reusing that water bottle, making sure you've got something that will last a long time. So using reusable items has a lower carbon impact than these single-use items. It's so much better use of our resources, and it saves money in the long term. And no litter. So just leave you with a couple of thoughts on things that you can do. So picking up on some of the ideas that Kirsty had said of what you can do, things like these doing a litter pick at your school or the park or the beach, these are fantastic things that you can do, and every action makes a difference. you can rethink your use of plastic. So making sure that you take your reusable water bottle to school. And using your voice to make a change. You know, we've seen this new rule come in to ban single-use plastic, which is amazing. And you can think about where that single-use plastic is being used. So does your school use plastic cutlery in the canteen? Is there a way, can you use metal knives and forks? Could you maybe find out if you could get a drinking water tap in your school to be able to top up your water bottle? There's all sorts of different ideas that you can think about, ways you can use your voice to make that change and reduce the plastic pollution in our environment. So thank you so much for joining us and for doing a fabulous job of keeping an eye on our little Barrys through the presentation. And you know what you're all waiting for, I'm sure. How many images of Barry the bottle did you see? Well, there were quite a few, I have to say. There were really quite a lot. In all of that presentation, there were 39 Barrys. Wonder if anyone saw 39 Barrys. So thank you so much for listening today. That's it for my presentation.
Thanks, Emma. Did anyone get how many Barrys there were? Did anyone get that right? I know I didn't. I must have missed a couple. I only had about 30, so oops. Anyway, on to some more answers because we'll just be really quick. And if you were doing our little quiz that we had on during the break, you might be interested to know what the answers were. And let's see. How many of these did you get right? First, we had pickle, our sandwich box. And you might be wondering, is there any plastic in this? Well, sometimes the little window inside the box is made of plastic. And I noticed someone saying that in the chat. So how long do we think that pickle would take to break down? I hope everyone got the right answer, which is 2 to 3 months in the right conditions. A sandwich box will break down because the majority of it is cardboard. And if the window is cellulose, like some of them are right now, then it will hopefully break down properly. If it's plastic though, you're right, that little window will just break into little pieces. And next we have a crisp packet and a sweetie wrapper. And how long do we think, and they are basically made of the same material, the foil covered plastic, which is why they're holding hands together there in the same question, because they take roughly the same amount of time. This one is rather surprising because did you know it takes 80 years for a crisp packet or a sweetie wrapper to break down. And as we know, it doesn't really decompose like compost does. It just breaks into small pieces, which is why it's important to dispose of these things properly. And now we have an aluminium tin from drinks. Sometimes those have plastic rings around them, but this time we're talking about the tin itself. And also sometimes these tins have a plastic lining as well, so that the drink inside doesn't react with the metal outside. And this one is rather shocking because the answer to this one is actually 200 to 500 years. Yikes! These are obviously best recycled because you can use an aluminium tin many times rather than throwing it in landfill where it takes a shocking amount of time to decompose. And our favorite Barry, can anyone guess how long it would take Barry to break into tiny pieces if he was put in landfill instead of the recycling bin where he belongs? They're rather frightening 450 years. That is longer than any of us will be alive. That is really not a good place for Barry to be. He really belongs in the recycling. Next, we have a styrofoam container, which are thankfully now, as Emma was saying, they're not available to be used anymore. Now, polystyrene or styrofoam will eventually break down in about 500 years, but only in the right conditions. And those conditions are not a landfill because styrofoam is sensitive to sunlight. That's called photodegradation. It's a nice big long word for you. And over time, sunlight breaks down the outer layer of the plastic, which turns it into a powdery substance. So that means that thin styrofoam packaging could break down, but inside a landfill shielded from light, that can't happen. And now we have Beanie, our takeaway coffee cup, which you might think, well, you know, it's probably paper, right? Well, actually, most coffee cups are not recyclable in with paper waste because they are coated with, you guessed it, plastic. And that's because if it was just a paper cup, your coffee would melt or make the cup rather soggy rather quickly. So unfortunately, these take 30 years to break down. And we did have a campaign in Glasgow to make coffee cups more recyclable, but obviously the best option is a reusable mug that you use all the time. And just hurrying up a bit because I know we have one more workshop. A pizza box, which you might think, well, that's cardboard, right? So yes, takes 2 months to break down. The cardboard bit does. Pizza boxes are the only item in our list that doesn't contain plastic, you might think, except that little table thing that you sometimes find to hold the lid. I had to find out what those were called. Apparently it's called a pizza saver. And those are typically made of polystyrene, which, as we know, takes 200 to 500 years to break down. So that's not good at all. And lastly, perhaps the most shocking one of all is chewing gum. And here you can see our very patient colleague Colin dressed up in our chewing gum mascot costume, which, by the way, you can hire our mascot costumes if you like. What you might not know is that chewing gum contains plastic. Gum is made of something called gum base, which includes a mixture of polymers, plasticizers, and resins with sweeteners, colorings, and flavorings. One of the main ingredients of gum base is polyvinyl acetate, which is another chemical name for a type of plastic, which is also sometimes used in the production of glue, plastic bags, and bottles. Yuck! So plastic is the ingredient that makes chewing gum chewy. And if you throw your gum on the pavement instead of putting it in the bin when you're done with it, it will stay there until your local authority cleansing team uses special equipment to clean it up. So if you think about it, it makes sense because gum is designed not to break down in your mouth while you're chewing it. So the answer to this question is never. Chewing gum will stay there until it is cleaned off and is quite shockingly, I don't know if you can see this because I can't see my camera. Let's see, here we go, there we go. Those are bits of chewing gum that were cleaned off of a pavement. As you can see, they're quite hard. So that's a bit scary, that one. And I think next we have the answers to our word search. Look away if you did not do the word search. If you did, how many of these did you get right? Let's see. Anyone put in the chat if they got all of the answers right, please? Right. So I think just now, because we are short on time, I will pass over to our next workshop, if that's going to work for us. And then I'll come back after that with a few more things that you can do. Okay. So Isabel, if you're there, I'd like to welcome you to come on and share your workshop. We're delighted to welcome Isabel, thanks to the Scottish Book Trust. And
hi,
thank you so much for spending your time with us.
Thank you very much. Can everyone hear me okay? And hopefully not too loud this time. Excellent.
I think you're doing great.
Great. So I am a children's author and I don't spend my days making up stories. I write about all kinds of things that go on in the real world. So all kinds of stories from the real world. I'll share a picture of some of the different things that I write. So let's find the right one. So hopefully now you can see a picture of all the books I've ever written for young people like you. Have a guess in your head about how many books I've written. I'll give you a couple of seconds. If you said about 200, you are spot on. So 200 books, that's a lot of facts. It's a lot of science in my books. But shall I let you in on a secret? I think it's a secret that all writers share, and probably all scientists too. Often, when I'm about to start writing, I don't know anything about the topic I'm going to write about, but I do know where I can find out. I always head to libraries where I can sort of read everything that people have found out who've come before me. So really all I need to get started when I'm writing a new book is questions, and these can be sensible questions, things like, why is the sky blue? Or, you know, what is an animal's life cycle like? But I think even better are silly questions. And I've been reading this week about a very silly question asked by scientists who are studying these animals. Does anyone recognize these animals? Are you thinking of an Australian animal beginning with W? If you are, you're completely right. This is a wombat. And there's all sorts of silly questions, you know, sensible questions we can ask about wombats. But these particular scientists asked a very silly question. They asked, why do wombats do square-shaped poos, cube-shaped poos? Do you want to have a look at the wombat's cube-shaped poos? There we go. So these haven't been specially shaped by the scientists. They've been collected, but this is exactly how they come out of the wombat. And you can see that wombat there not looking very pleased that we're having a look at his poos. So these scientists asked, you know, why are these poos square shaped? And this silly question led to some very, very interesting science. They found out that the wombats are actually piling up their square shaped poos so they don't roll away because they're not spheres, and managing to make little piles, a bit like poo Lego, and they're using those to communicate with other wombats. So these silly questions can lead to some brilliant, brilliant science. Now, let me just end my screen share. Hopefully you can see me in the screen again. Today I'm going to start by talking about a scientist who asked a silly question about plastic, and it was a question that ended up changing the world. And I wrote about the scientist in this book, which is called How to Change the World. The scientist was called Nathaniel Wyeth, and he was living and working in the 1960s, so around about 60 years ago. And he worked for a company that made lots of everyday products. And one of the products they made was bottles like this to hold fizzy drinks. And as you can see, this is a glass bottle with a fizzy drink inside. And he asked, hang on, why don't fizzy drinks come in plastic bottles? Because plastic had been invented by then, and plastic was a lot cheaper and a lot lighter than glass. And plastic didn't break as easily as glass either. But to his surprise, his co-workers just started laughing and said, that is a really, really silly question. He said, well, why? And he said, well, look what happens. It's okay if the drink's just sitting here doing nothing, but what happens if we shake the bottle? All of the carbon dioxide inside starts to escape, and you can see the bubbles building up at the top. And when that happened inside the types of plastic they could make bottles from at the time, the bottle would typically explode. And this morning I made a little video to show you what would happen. I can't do it here in my study because we might make things a bit messy, but if I start sharing my screen again, I can show you a little video of what happens. So we can see what happens when bubbles of carbon dioxide form in a plastic container. I've got a vitamin C tablet container here with these fizzy vitamins, and I've just pushed the last tablet into the lid here. I'm going to put it on very carefully so it doesn't drop into the water yet, and then I'm going to place it upside down and mix it with water and see what happens. What do you think is going to happen? And there we go. So what happened, we'll play it again in slow motion to have a look, is that those tablets, which are made of bicarbonate of soda, release carbon dioxide, and so quickly in the water that the bubbles of carbon dioxide built up really fast in the bottle. And the weakest part, which is where the cap meets the bottle, just came apart and the bottle exploded. And that was exactly what was happening to Nathaniel's bottles at the time. But he did not want to give up. He was determined. He became obsessed with making a type of plastic bottle that would work. And he wanted to do it by trying to make plastic a bit stronger by blowing it like glass. So when we make things like this glass bottle here, we basically start with a balloon shaped piece of glass and we blow air into it so it gets bigger and bigger. So he wanted to try and do that with plastic. But the problem was that all the types of plastic they were typically using to make containers would just have weak parts. They weren't strong like this latex balloon. They'd have weak parts and all the air would escape and the bottle would pop. So every time he did this, blowing up a piece of plastic inside the mold, he'd open the mold, look in it, and just find things like globs of exploded plastic or really cloudy plastic where it had stretched in different places, or just bottles that had split open altogether. He really wasn't getting anywhere. Now, how many times do you think he tried to solve this problem before he gave up? I want you to just have a couple of seconds to think about it. Think of a number and tell your teacher so they can put it into the chat. I'd love to see your guesses about how many times you think Nathaniel tried before he gave up. Someone's guessed 12 already, 100, 350, 530, 300-ish, 51, 250, 500. These are brilliant guesses. I think 500's the biggest time. Oh, 950. Lots of fantastic guesses. Okay, I'm going to tell the answer now and see who got closest. I just saw 1,000 there. It was actually 10,000 attempts. He made 10,000 different bottles before he hit on a process that would work. So he was absolutely amazed. You can imagine you made 10,000 different bottles. They've all been a failure, but you're determined not to give up. And one day he opened up the mold with the plastic in, where they'd blown the air through the plastic into a bottle-shaped mold. And it looked completely empty. And then he suddenly realized it wasn't empty. There was a crystal clear plastic bottle inside. They'd actually managed to invent a plastic bottle that did work. And they did this by using, I'm going to share this word with you because it is an incredibly long word and I think it really helps to see it on screen at the same time. I don't want to wait. You won't see me again. So we're blowing the air through this little kind of plastic, this is how it starts off, plastic container, and ending up with a bottle. And the plastic they used was an extra stretchy elastic type of plastic called polyethylene terephthalate. Can you say that along with me really slowly? Let's have a go together. Polyethylene terephthalate. Let's say it a bit faster. Polyethylene terephthalate. Let's see if we can say it really, really fast. Polyethylene terephthalate. There you go. Now you're expert chemists. Now you can say these long words. But scientists, you know, like us, they don't want to spend loads of time saying and writing long words. So they shorten that to PET, which looks like the word pet. So we can just say PET and it means polyethylene terephthalate, that type of plastic that's now used to make plastic bottles. So Nathaniel had invented this perfect lightweight, see-through, fizz-resistant bottle that didn't explode when you put fizzy drinks in it. And that became the type of plastic used to make bottles all around the world and still is today. And here's a video of plastic bottles being made. You can see how you start off with this little plastic balloon and then it gets heated up in an oven so it gets really stretchy, and then it gets taken out and put into a bottle-shaped mold which gets clamped shut, and then air is blown into it. So there it is in the mold, little balloon going in. Air is blown through it just like I did into the balloon, and when it comes out it's a plastic shaped bottle. And billions of bottles are made like this every year. In fact, more than 480 billion plastic bottles are sold around the world every year. And if you place these all end to end, they would wrap around the world about 1,800 times. And that really is exactly what's happening. They are being wrapped around the world because, as we've seen, every year millions of tons of plastic litter, including bottles, are making their way to the oceans, where they're collecting in these giant floating garbage patches. And that amazing thing about PET, that it was almost indestructible, is now its biggest problem. So while the paper or the cardboard, as we saw in the quiz, might rot away in just weeks, a plastic like PET takes at least 450 years to rot away. And even then, it doesn't decompose completely. It just breaks into smaller and smaller pieces. And as we heard earlier, those tiny pieces, which we call microplastics, are doing huge damage to the creatures. And I'll go back to our seagull. I'm going to swap to a different camera now, hopefully, and then we can have a look, a close-up look at some of these micro pictures. So let's try swapping to this camera, and now hopefully you can see a view of my desk. Hello, here's my hand kind of waving at you. Now, not all microplastics are things like plastic bottles that have broken down. We also have, as we saw before, plastic being transported around the world in its raw form. And I've got here some of those little plastic nurdles that we saw before. So microplastics in the ocean can be things like these little nurdles, which is the way that plastic is transported around the world. As you can see, they're pretty small, as my finger for size. And they spill really easily. You can see they've already fallen off this tray that I've got here. They spill very, very easily into the ocean when they're being loaded on and off ships. So there are absolutely tons of these in the ocean every year. Now, someone said earlier in the chat, what is the smallest microplastic? And even though these are quite small, they're not the smallest. Some of the smallest microplastics come from our washing machines when we wash clothes. And I've got some collected here. This is actually from a tumble dryer. And you might have noticed these tiny little fibers collecting in things like tumble dryers or sticking in the pipes of washing machines. And they're actually tiny, tiny pieces of clothes that are made from plastic. So tiny fibers from clothes being washed away. So these are some of the absolute smallest microplastics. You can see if you try and get close up that each one is just like thinner than one of the hairs on our head. Absolutely tiny pieces of plastic. And scientists think that, let me just switch camera back again so you can see my face. Hi, I've reappeared. Scientists think that if you added up all of those tiny, tiny pieces of plastic that are in the ocean, there are somewhere between 15 and 51 trillion particles of plastic, or microplastics. Now, these are bigger, you know, trillion is a big number, and a billion is a big number too, and even a million is a big number. And we kind of hear these numbers, and we see these numbers in presentation, and it's really hard for our brains, because we don't see numbers that big around us. It's hard for our brains to imagine just how big those numbers are. So I wanted to do a quick little quiz now. I'm going to switch back to that camera so you can see my desk. So we're back where my hands are. And I want you to just have a think. You don't need a piece of paper. You can just tell your teacher what is happening and ask them to put the answer in the chat for us. That may be, you may be seeing that sort of back to front, but basically I'm asking you to guess if you were going to count to 1,000,000, saying one number every second. So if we count to 10, 1, 2, 3, 4, 5, and so on, we might take 10 seconds. If you were going to count to 1,000,000, how long would it take you? And I don't want to give you the answer in seconds. Try and think of what the answer might roughly be, you know, in hours or days or weeks and so on. How long would it take you? Yeah.
You're frozen, so we can still see your face. We can't see what you're showing us. Could you try changing your camera again, please? We'd love to see what you're showing us.
Hi. Can you see my face again?
Yeah, I can still see your face, but you're frozen. Oh, yeah, you're frozen.
Oh.
Uh-oh.
I can still hear you really well.
Yeah, we can still hear you. We just can't see what you're trying to show us. When you switched camera, it just went, oh, there we go. That's much better. There
Oh,
we go.
is it woken
Thank
up
you.
again? Did you hear my voice though for that?
Oh, yes. We
Yeah.
just didn't want
So
to
you know
miss what you were showing us.
So you've had a bit of thinking time as now, a bit of extra thinking time. So I'd like you to, I think you're probably seeing this back to front anyway. That's just due to the settings of like the Teams app. So just think about how long would it take you to count to 1,000,000? How long would it take you to count to 1,000,000,000? And how long would it take you to count to 1,000,000,000,000? So have a quick think and pop your answers in the chat and have a look. And while you're thinking about it, I'm going to switch back to this camera. Am I still appearing on the face camera now?
We can see your face now.
Great. So I'm going to switch over to the chat to have a look at the guesses. So we've got one guess says a day for 1,000,000, 3 weeks for 1,000,000,000, and 1 year for 1,000,000,000,000. And someone has also guessed a week for 1,000,000,000. Someone's guessed 200 days for 1,000,000, 500 days for 1,000,000,000, 100 days for 1,000,000,000,000. Brilliant. Keep on putting your guesses. I'm going to write the answers down so I can show you. So hopefully everyone's had a chance to put a guess. I've looked through your guesses. I haven't seen anyone who's got one spot on, although some people are going into years, which is a good thought. I'll tell you what the answers are. To count to 1,000,000, it would take you, remember, one number every second would take you 11 days. Some of you have got a guess a bit like that. To count to 1,000,000,000 with one number every second would take you 32 years. 32 years. So by the time you finished, you would be older than your teacher is now. To count to 1,000,000,000,000, and this is the one that really boggles my brain. So counting to 1,000,000,000,000, one number every second, don't even get a chance to stop to eat meals or go to the loo. It would take you 32,000 years. 32,000 years to count to 1,000,000,000. So that really shows us when we say there's 15 to up to 51 trillion microplastic particles in the ocean. That is a huge, huge number, which is hard for us to even imagine. And then you can imagine how it's very possible that scientists are finding out that 9 out of every 10 seagulls we see, for example, have plastic in their stomachs, whether it's a big piece that they've swallowed, like a broken down plastic bottle, or if it's tiny pieces, like those little fibers from our clothes that we looked at. So science is about asking questions. Science for Nathaniel was about solving the problem of how to transport fizzy drinks, and he didn't realize, of course, at the time what other problems that was going to cause by making this new type of plastic. Can science solve the problem of plastic for us? Now that's a question I tried to look at in a different book, and this book is called The Book of Hopes. And you might have seen this book around the time of the first ever COVID lockdown. It was put together by Catherine Rundell to raise money for NHS charities, and she asked 100 different authors, our names are on the back, to write a very short story that would give people hope. And as I said at the start, I don't make up stories. I like to write about real world stories. And I found hope for my story in a very unexpected place. Can you guess who my plastic hero is going to be? Have a guess, see what kind of thing is forming in your mind, and I'm going to share a picture now. Oh, let's just go back here. Okay, so it's not my seagull. I'm going to reveal it now. Oh, has it frozen again, or is it okay?
We can see you.
You can still see me. It's getting
But
very glitchy, isn't it? Can you see a picture now?
no, we can't see your screen. We can just see you.
I'm going to try sharing again. Okay, can you see now?
Oh, that's better.
Excellent.
That's got it.
I'm glad I cracked it in the end. Was anyone picturing this when they were thinking of who our plastic hero would be? And can anyone guess what it is? Pop some suggestions in the chat. I'm going to actually read you the whole story because it's quite a short story. I'm going to read you the whole thing while you have a good look at our plastic hero. If hope were an animal, would it be a unicorn cantering through sunlit clouds? Or maybe a hippo that burps rainbows? Or could it be a creature that most people barely notice? A small, plain caterpillar crawling on 6 stubby legs? Our unlikely hero is the caterpillar of the wax moth, an insect with a very bad reputation. Now, wax moths like to lay their eggs in honeybee hives, and when the creamy white caterpillars hatch, they tunnel deep into the honeycomb, chomping their way through beeswax, pollen, and honey, and generally causing chaos. Scientists who study wax moths are usually looking for ways to stop them in their tracks. But one day, someone noticed these caterpillars have a superpower. Federica Bercaccini was cleaning out her beehives when she found a few wax moth caterpillars. Now, knowing that they're bees' #1 enemies, she popped them into a plastic bag while she finished the job. But when she returned, the bag was full of holes. The caterpillars had eaten their way through the plastic and were making a slow getaway. Some people would have found them a tougher prison and forgotten all about it, but Federica's a scientist and she was curious. She knew that plastic bags are made from polyethylene, a type of plastic so incredibly tough that blazing sunshine, biting wind, churning water, and ravenous microbes take at least 100 years to break it down. This indestructibility is why most of the plastic humans have thrown away is still piled up in landfills, clogging up rivers and floating in oceans. So how on earth had 3 small caterpillars destroyed a patch of plastic in just a few hours? Working with her colleagues, Federica began to investigate. They discovered something astonishing. The caterpillars weren't just chewing plastic bags into tiny bits and pooping them out. They were actually digesting the plastic and using it as food. The next step was to find out how. The world has herbivores, carnivores, and omnivores, but no one had ever met a plastivore before. 3 years after Federica's discovery, another team of scientists found the second piece of the puzzle. Wax moth caterpillars have friendly microbes living in their stomachs. These microbes usually help the caterpillars to digest beeswax, which is nature's version of plastic. But if the hungry caterpillar decides to eat human-made plastic, they're happy to switch and digest that instead. Together, caterpillars and microbes are an unbeatable team. Now, it would take 60 caterpillars a week to munch their way through a piece of plastic about as big as your hand. They won't be able to solve the world's plastic problem on their own, but they give us hope we can find solutions if we can understand the wax moth caterpillars' plastic pulverizing powers. We might be able to copy them and find a way to break up plastic into particles that can be returned safely to nature. So you're doing brilliantly so far. You've listened to so much this morning already. I have about another 5 minutes to go, but should we just have a wiggle like a waxworm first to wake our bodies up? So you can do this standing up where you are, or you can do it sitting down. I'm going to stay sitting down so you can see me. And I just want you to wiggle a bit like those caterpillars you just saw. So can we have a bit of a wiggle in our seats, wake up our bodies? Maybe we can get really long. Maybe we can do some plastic eating with our hands at the top. Excellent. And shake it out. They spend all of their time wiggling around like this, and they never really have to sit still. Brilliant. So everyone sit back down now. Brilliant. Big breath, and we'll carry on with the last 5 minutes. Now, I said at the end of that story, waxworms, as cool as they are, and scientists, as cool as they are, and as curious as they are, cannot save the planet alone. In the 2 minutes it took me to read that story, another 2 million plastic bottles have been bought in shops just now in the last 2 minutes. And they're beginning that journey that ends up in the stomachs of fish and seagulls and whales and those beautiful, beautiful sea turtles we saw earlier. So plastic pollution has become this planet-sized problem, and we need all of us to solve it. So what can we do? What can we do from our homes and from our classrooms? Now, I set out to ask this question in this last book I'm going to show you today, which is called This Book Is Not Rubbish. I set out to find 50 things we could all do to help clean up our act. We don't have to do all 50, no one has to do all 50, but they do give us some ideas of things we can do. And some of them were really surprising. So let me just share my screen again and shout if this doesn't work again. I'm quite determined to crack it eventually. Is that looking okay to everyone?
Yay, that's worked.
Excellent. So if I just go on to the next slide, there's our poor whale with his stomach full of plastic. This is one of the pictures that Alex Patterson drew for this book. And some of the tips in this book are really strange when you first read them. This is just some headings. Be annoying. We're going to come on to that in a few moments. Wee in the shower. This really can help to save a lot of energy and water. Eat more chips. Now that isn't quite as fun as it sounds, but if you read the book, it all gets explained. Don't hand in your homework. And again, this sounds very strange to start with, but then we find out that maybe if we don't actually hand in pieces of paper, but do it digitally instead, we can make a big difference in how we use resources. And the last one's perhaps the strangest of all. Stop recycling. Stop recycling. Now, how can that be when we've heard that, we keep on hearing, there's messages to kind of recycle. And, Nathaniel, going back to the inventor of those plastic PET bottles, he didn't know it at the time, but PET plastic's actually really easy to recycle. It's actually the world's most recycled plastics. This was kind of one silver lining of this big problem. With 41 bottles, which you can see in the corner here, you can make 1 square meter of carpet. So have a look, if you have like a reading carpet in your classroom, how many plastic bottles would that take to make? 5 bottles can be used to make 1 large t-shirt. And 5 bottles can also be used to make enough padding for 1 padded jacket, whether that's for our pretty cold looking pet here, or if that's for a human. So, this plastic can have a second life if it's recycled. But there are 3 big problems with relying on recycling as the solution to the plastic problem. The first is that recycling takes a lot of energy. The second is that plastic like PET can only be recycled about 10 times before those long stretchy chains that we saw earlier. Can you see me okay at the moment? Just getting a strange message popping up. Brilliant.
Yes, we can see you.
Great. Plastic like PET can only be recycled about 10 times before those long stretchy chains that make up the plastic just get too weak and they just split apart, just like the old plastics that Nathaniel had problems with. So recycled plastic has to mix with new plastic, which means more nurdles like this going around the ocean just to make recycled plastic. And the third massive problem is that we are still really bad at recycling. Now, we mentioned earlier, of the 8.3 billion tons of plastic that's ever been produced, only 9% has ever been recycled, which is around about 6 billion tons, 5.7 to 6 billion tons. is still out there if only 9% has been recycled. So it's still out there in landfills, it's still out there in the ocean. We see plastic gathering at the sides of the roads that people have discarded. It just sits there. Now, again, 5.7 billion tons of plastic out there in the world not being used just kind of as litter is a lot, but it's hard to imagine, isn't it? So I've done a comparison that can help us imagine how big that is. It's the weight of all the humans on the planet times 18. So a huge amount of plastic still out there. And it's immediately clear to see when we hear those numbers that recycling on its own is definitely not working. So how can we change our ways? Now, can you see my shared screen at the moment? Can you see that okay? Are you seeing?
Yes, we can see your screen. That's no
Great.
problem.
Picture of a turtle at the moment with this poor turtle. Alex drew this turtle, has got a particular type of plastic in its nostrils. It's got drinking straws, plastic straws. And the world has been thinking about plastic straws for a long time. And the world realized that straws really suck because they're so often found actually lodged in the nostrils of sea turtles or tangled up in the stomachs of penguins. So people have for quite a few years now been trying to use less plastic straws and replace them with other things. Have a quick think in your head. You could just chat with your partner. How many different alternatives, so different other options, can you use to make straws? See what you could think of. If you like, your teacher could pop some of the ideas into the chat. And you can have a look at what other people have come up with. I'll give you a few moments and then I'll share my list and see if you came up with all of those or if I found some that might surprise you. Okay, so let's have a look and see. So who said metal straws? Completely right. There's been metal straws around for quite a long time with this little brush next to them to clean them. We've got silicone straws. Now, silicone is the material that sand is made from, that glass is made from. So it can be one way to make reusable straws that can be washed and used again. We've got glass straws. Now, this might have the problem of being a bit fragile, but they have the bonus, I suppose, that you can see the drink going up the straw. People make cardboard straws. You've probably seen these. And bamboo straws. Now, bamboo is a plant that grows very quickly. So maybe, you know, it's renewable. Once it's cut down, it can be grown again. It does rot down. So maybe a better option. Cardboard straws that look like bamboo. These very strange straws I found made from the pits in the fruit, avocados. So they're actually ground down and made into material that can be used to make biodegradable straws. Straws made of seaweed. So these are actually made from the algae known as seaweed. And after a few uses, they just sort of dissolve away. Last of all, straws made from actual straw, which is how straws started off in the first place. The actual stems of large grasses that are sort of left over once those crops are harvested can be used and are used and sold as straws. But can you see a problem with all of these? Although they're not made of plastic, they are still using energy and resources to make them and to transport them to shops. And they're still producing litter that gets thrown away eventually. So it's far better to just stop using straws altogether. And you've probably come across the mantra, reduce, reuse, recycle. And when I said stop recycling, I was really just trying to remind people that recycling is a last resort, is the last thing we should think of doing. Before that, we should say, can we reduce what we're using? Can we reuse things instead of buying something new? And then finally, if we have had to use and buy something and we need to get rid of it or it's broken, can we get it fixed? But if not, can we recycle it? So this shouldn't really be too hard because remember, PET wasn't invented till the 1960s and 1970s. And before that, there are at least 100 billion people in the world who still manage to, drink not using plastic bottles. Plastic's really just a bad habit, and it's up to us all to break it. So you can start with places you're in control, like, for example, your birthday or your class end of term party. These things only happen every so often. So sometimes when people have parties, they just go, okay, well, we're just going to have this for one day. So we're going to get all this disposable stuff, wrapping paper that we throw away, cards, decorations, paper plates, napkins, plastic cups, decorations, and then it all goes in the bin at the end. But it's actually really fun to come up with alternatives. So one thing you could do in class is try to, first of all, imagine your perfect party. Write down everything that would be there if you got invited to this party that's in your mind. And then try and imagine what you could do to replace everything that's made of plastic in that image in your head with other things. And it could be really fun ways, fun ways to wrap a present without using disposable paper covered in plastic. Fun alternatives is the glitter. One school in the UK has started to use lentils instead of glitter, but I don't recommend it if you're going to decorate your base. Maybe you could think of, instead of a plastic party bags, what are plastic-free alternatives that would be super fun, like decorating little cakes to eat, or even making homemade slime, for example. So when it's your party and your home or your school, you can be really bossy. Now, sadly, you're not, and I'm not, sadly, in charge of making rules for the entire country. But do you know what? No matter how young you are, you can influence the people who do make the rules, people like your school leaders and people like politicians, either in local councils or in government. And when people like you ask politicians to make change, this can have the biggest impact of all. Now, if we look at plastic bag use before the law was changed to make people, politicians decided, okay, we've got to do something about plastic, change the law to make people pay for plastic bags, just a few pence, but it made a huge difference. Before that, people were using an average of about 116 plastic bags each a year in the UK. And once that law came in, it went down to only about 20 or so bags each a year. And the longer time kind of goes on, the more people break that habit and get used to it. So in Denmark, for example, where plastic bags have been charged for 20 years, 25 years now, people only ever use something like 4 different plastic bags a year, and that includes things like sandwich bags. So changing the law can have a really big impact. And of course, we saw earlier, Scotland's passed a law brilliantly banning single-use plastic cups and cutlery and plates and most plastic straws, except for when people really need to use them. There are things like if people have operations, maybe teeth removed, they have to use a plastic straw for a little bit, and that's absolutely fine. It's just stopping using them when we don't really need to. So could we ask our leaders to do the same thing with those plastic bottles? I want to leave you with the challenge of raising attention with leaders. And you could start with your school leaders. Think who's in charge in your school. Try and make a poster. You could use this quote on it, which is from Nathaniel Wyeth himself. He said, don't be too quick to accept the way things are being done. Question whether there's a better way. So don't just kind of look around and say, well, everyone else is doing it, that's how it's done, that's fine. Always be brave enough to question whether things could be better. So you could put this up at school to try and get leaders to make rules that influence plastic use, or maybe any sports and clubs you could do. You could display your posters there to, again, ask leaders to make a really positive change. And if you want to go one step above, you could write to your local councillors and your MP and tell them what you've learned today in these workshops and ask them to take action on plastic. And to help you do that, I've given all of your teachers a template letter which you can use, and you can brainstorm ideas together and write your own letters, or write a letter as a class telling them about these workshops, what you've learned and what you would like them to do to take action on plastic. Now I'll just end my share so you can see my face again. Thank you so much for listening today, and thank you for all your input. into the chat. It's been a real pleasure. Thank you.
That was amazing. Thank you so much. I'm completely blown away by how long it would take to count to a trillion. What? That's really is amazing. And to think that that many pieces of plastic floating around somewhere is actually quite sad. But I do like that you've given us a lot of things that we can do about it. So, and I just love the titles of your books that people can see on the screen just now. I like the bedtime book of impossible questions. I think I might need that one myself. I might need to read that one myself. Looks good. No, thank you so much for taking the time to be with us today, to share your wonderful writing with us. And thank you so much to our friends at the Scottish Book Trust for helping to make sure this workshop could happen, that you could spend your time with us today. Thank you. Remember, if anybody has any questions for Isabel, I mean, I know I have about 50. Maybe you could email them to us at ecoschools@keepscotlandbeautiful.org.
Oh, somebody asked, why should we wee in the shower?
Yeah.
Well, this is actually something
that was coming.
Scientists, so I didn't just make it up in my head. Scientists did a big study actually in East Anglia, where I live. Like I live in near Cambridge in the UK, and they got students from East Anglia to just do their first wee of the day in the shower. And of course, not everyone wants to, and that's absolutely fine. But it's not harmful to do it at all. And the amount of water they saved was absolutely enormous. Like it was basically a quarter of the kind of water use in their homes just by saving that one flush of a loo every day. So it's just kind of giving that idea that, I mean, not every single person has to do every single idea in the book, of course, but it gives that idea that just because something sounds a little bit silly when you first hear it, actually, if it could be worth looking into and could make a really difference.
That's a very interesting study. And of course, to make sure everyone out there, when you are flushing the loo, to flush only the things that should be flushed. One of which is toilet paper, and I'm sure you can guess what the other two are. Please don't put them in the chat. But nothing else, no plastic, no razor blades, no nappies, nothing else. Just to wrap up our lesson, remember, we have so far learned a bit about the history of when plastics were first invented and why and what they're made of, and how some aspects of plastic are actually good and have helped humanity in many ways, but also how some aspects of plastic are actually negative and are hurting our planet, especially because we produce and discard so much of it. And unfortunately, because most of it's still lying around somewhere. And I wanted to leave you with a thought. How did we end up using so much of something that's destroying our planet? And we're going to think about one example in particular. And I do know we're running over time, so I will be very quick. Going to have a look. Do we really need bottled water? Now that we have a better picture of where plastics have come from and why, and how amazing they seemed at the beginning because they solved so many problems, but how some of those solutions to problems are actually causing more problems, especially since we live in a country that has great access and quality of drinking water. Do we really, really, really need water in a bottle? You might be surprised to learn that we have actually been sort of tricked to think that not only do we need bottled water, and it's not only good, but even better than drinking tap water. And we've been convinced to such an extent that in the UK alone, for example, we have consumed around 2.5 billion, there's that number again, liters of bottled water in 2021 alone. Together with all other bottled drinks in the UK, we consume around 36 million plastic bottles every single day. That's 36 million every day. Yikes! 25 billion litres of bottled water drank in the UK in 2021 and 35.8 million plastic bottles every single day. Yuck. You might be surprised to learn that we actually have the best tap water, sorry, not bottled water, some of the best tap water in the world. So why are we using plastic? Well, there's that trick again. And I think if you want to learn more about this, have a look in the resource folder for something called The Story of Bottled Water. And in there, you can learn about how we've been tricked to use bottled water and what other sorts of things that has been done with. You maybe, is it just bottled water? No. Can you think of other products that we consume that we think are normal and necessary, but years ago didn't exist and people were perfectly fine without them? Maybe we can be perfectly fine without them again. We'll leave that question with you in your classrooms, and hopefully you can have a good discussion about this and we can come back to it at our assembly on Friday. I also wanted to remind you that good things are happening, because we don't want to leave you with doom and gloom. Remember, on March 2022, the leaders of 175 nations have signed a historic resolution to end plastic pollution. So there are lots of people out in the world who are working hard to make things right and build a better place for everyone. And as Emma mentioned already, in August this year, Scotland has enforced new rules to ban some items of single-use plastics. I wonder if you can think of other single-use plastics that could be added to this ban in the future and what we could use instead. So don't forget, we can make the difference, we can be the difference, and we are already being the difference. I want you to say hello and share your work, especially all your comic strips that you might be making in your classrooms this week, or your lights, camera, plastic videos. I would love to see your work, and we'd love to share it with everyone else who will be joining us. We'll showcase some on Friday's assembly, and also we can share it on social media. Please share with us either at KSB Scotland on all social channels, or you can email them to us at ecoschools@keepscotlandbeautiful.org. And when you email us things, please let us know if it's okay to share them with everyone else. We look forward to seeing you on Friday if you're able to join us then. And want to thank you so much for taking the time to join us today. Thank you to Emma and to Kirsty and to Isabel as well. And thanks to all of you as well. So that's us for today. Hopefully see you Friday. Have a good rest of your week.